Hello students, welcome to JCE Connect series of lectures. So in this particular lecture, we'll continue with some more problems on impact of jet on curved vanes, considering the velocity triangle. So in this particular session, I'll be taking a problem as a jet of 60 millimeter diameter impinges on a curved vane and is deflected through an angle of 165 degree. The vane moves in the same direction as that of jet with a velocity of 25 meter per second. If the rate of flow is 190 lps, determine the component of force on the vane in the direction of motion. The next, how much would be the power developed by the vane and what would be the water efficiency, neglect, friction. So this is the problem given, and first you need to write the given data. What are the data given here? The diameter of the jet is given 60 millimeter, so 0.06 meter, and the area of jet can be calculated. Then that is pi by 4 d square. Then angle of deflection is given, that is 165 degree. Then the velocity of vane both at inlet and at the outlet, that is u1 equal to u2 equal to 25 meter per second. The rate of flow is also given, that is a discharge, q is 190 lps, that is 0.19 meter cube per second. So in this problem they are not mentioned at what angle the jet is striking the vane. Since the jet and vanes are moving in the same direction, so let us take the jet is entering tangentially into the blade passage. So let us draw the velocity triangle. See, this is the vane, this is the curved vane, like this. Let us take at inlet the jet is entering tangentially into the blade passage. Since it is entering tangentially, and also the angle made by the jet at the inlet will be 0. So here we need to consider alpha equal to 0 and theta equal to 0. Both are 0 here. So the velocity triangle will become here a straight line. So at the inlet, since they are not mentioned at what angle the jet is entering, so if they are not mentioned, you have to take the velocity triangle at inlet of this particular problem will be a straight line. Now, so you can mark on this straight line only. So let us take this point as a and this as a B, and this you mark as a C here. So A to C represent u1 velocity of vane. Then this will be what? VR1. Then from here velocity, that is from here to here will be V1. So in this one inlet velocity triangle, V1 will be equal to VW1. And in this problem the velocity of whirl will be 0. Since the inlet velocity triangle is a straight line, it is giving a straight line, so we can mark only the velocity of the vane, because the vane is moving in this direction, and the total velocity, the absolute velocity will be v1. So it is v1 equal to vw1, and vr1 is the relative velocity, that is v1 minus u1, which can be represented as cb, the line of cb. Then after striking the jet, so jet is striking like this, then after striking this it exits like this. Then you can mark like this, then this will be V2, and this will be, this is U2 and this is VW2, and this will, this one VR2, and this angle is beta. Then this angle is pi. Then this will be VF2, the angle of deflection. You can take angle of deflection here. This angle of deflection is given 165 degree. Then this angle will become 15 degree. So this is the angle of deflection. So this is the pi, and this angle equal to this angle. Okay. So this will become VR2, outlet velocity triangle. Okay. So after this, once you have drawn the velocity triangle at inlet and at outlet, so at inlet velocity, this is the inlet velocity triangle. See, inlet velocity triangle, this is outlet velocity triangle. Okay. So inlet velocity triangle will be straight line, where AC represents, that is velocity of vein, where CB represents relative velocity and AB represents absolute velocity. Okay. Then in this particular triangle, that is inlet velocity triangle, V1 is equal to VW. You will get only whirl velocity, that is a component of V1 in X direction, but component of V1 in Y direction will be what? 0. So you will get 0, that is flow velocity will be 0. But as it enters the blade passage, and exits, so the moment it strikes the vein, it will deflects. The deflection angle is given 165 degree. Okay. So that is a angle between VR2 and horizontal. Take this angle equal to this angle. This is also pi, and actually this is also pi. This angle equal to this angle, and this angle equal to this angle. Okay. Now solve this one. Okay. You can write one line here. Since the jet of water moves, in the same direction as that of vein, therefore alpha equal to theta equal to 0, and also the inlet velocity triangle will be inlet velocity triangle will be straight line. Okay. Therefore V1 equal to Q by A, because we know Q equal to A into V. So V1 equal to Q by A. Then Q is 0.19 divided by 0.002827, we get 67.198 meter per second. Also VR1 equal to what? V1 minus U1. So that is 67.198 minus 25, we get 42.198 meter per second. Then VW1 is equal to V1 is equal to 67.198 meter per second. also. Then from outlet velocity triangle, referring outlet velocity triangle, the angle pi will be 180 minus 165, you get 15 degree. Since the vein is smooth, VR1 is equal to VR2 is equal to 42.196 meter per second. VR1 is equal to VR2 is equal to 42.196 meter. Therefore, from outlet velocity triangle, so this one, if you refer this outlet velocity triangle, so this is U2 and this is VW2, and this will be up to here. This is VR2 cos pi. Okay, VR2 cos pi. Then what VR2 cos pi can be written? So VR2 cos pi. So VW2 can be written. VW2 will be VR2 cos pi minus U2. Then you know VR2 42.196 into cos of 15 minus 25, then 15.76 meter per second. Okay, so once you get a VW2, then we can easily get the force exerted by the jet. Force exerted by the jet on the vane, in the direction of motion of vane, then Fx can be written. Since in this problem you look at this one, so here beta, just look at the angle beta, so which is less than 90 degree. Here beta is less than 90 degree. So for acute angle we write rho a VR1 VW1 plus VW2. So you know all here, VW1 also you calculated, VW2 also you calculated, then area, then substitute all the values here. Density is 1000, area is 0.002827, then into 42.198, then into 67.198 plus 15.56, 15.76. Okay, then answer you will get 9896.37 Newton. This is the force exerting by the jet on the vane. Then work done per second. So we know the formula Fx into U. Then 9896.37 into 25, you get 247409.26 Newton meter per second. Okay. Then power developed by the vane So power will be, so you'll get 247409.26 divided by 1000, we'll get 247.409 kilowatt. Okay. Then efficiency of the jet can be written work done per second divided by kinetic energy per second. So already we calculated work done per second, then only calculate kinetic energy per second. that is, we know half rho a v cube, or you can write half rho q v square, because q equal to a into v. Then substitute here, you will be getting, that is half 1000 into 0.19 into 67.198 square. So you will be getting here, just calculate 1000 into 0.19 into 67.198 square divided by 2, you will be getting 428.97 into 10 raised to 3. 10 raised to 3 Newton meter per second. Newton meter per second. Then substitute here. So we know the work done per second, 247.409 into 10 raised to 3 divided by 428.97 into 10 raised to 3, you will be getting 47.409 divided by 428.97, you will be getting 57.67%. This is the efficiency of the jet. Okay, I hope you understood here. So in this problem, the important thing here is, so when the entry angle, that is a jet entering the vane passage, if not given, you have to consider this as a 0. Alpha equal to 0 and theta equal to 0. Alpha is what? Nozzle angle, and theta is the angle made by relative velocity with horizontal. And when both will become 0, so in this case, as you know, the component of V1, so V1 is what? V1, that is a VW1, sorry, component of V1, you can write, so VW1 will be V1 sin alpha, and VF1 will be V1, sorry, this is cos alpha, this is sin alpha. Okay, then VW1 cos 0 is what? 1, then V1 is equal to VW1. Sin 0 is 0, then VF1 will become 0 here. Okay, so the inlet velocity triangle will be what? Straight line you get. Okay, then mark the vane velocity and the relative velocity and the absolute velocity in this inlet velocity triangle, and the outlet velocity triangle. As the jet strikes, it deflects by an angle of 165 degree. The deflection angle to be taken, that is angle made by the VR2. When you draw VR2 and project that tangent and join to the horizontal line, you will be getting this deflection angle. So total angle is 180 degree, 180 minus 165, you will get 15 degree, and that 15 degree is this one. Okay, then again you draw the VR2, then you will get a beta. Beta is less than 90 degree, hence the equation will be VW1 plus VW2. Okay, so the drawing of velocity triangle is very, very important here. Once you draw the velocity triangle, then it is very easy to calculate the force exerting by the jet on the vane, as well as the power developed by the jet and efficiency of the jet. I hope you understood this problem. So practice this kind of problems, and generally this type of problems should be asked in exam for 15 to 20 marks. Okay, sometimes. So 15 to 20 marks. Thank you.